have to shoot the video on the first backtest model that I create. I just want to help myself to remember. CD, and I go to D drive, and let's go to my virtual environment. I like this one because I forgot my tray scripts, and then I go to python.-m-idle-lib.idle. I'm not using Sublime Text because this is the one that I just did, starting from $10,000, and it's buying the Hong Kong Stock Exchange. Just close that. I think this time I'll just do the Google one because it's easier. Maybe. And I just put Control-O, just open up the file that I'm going to do. This is the example, and just copy Control, and I just change the name. Just getting lazy. Example 2017 1101. Let me open that up. The very first part, before anything, is going to be grabbing stock from website, and I save it to an Excel file. So I need to import pandas data reader as PDR because I need to grab stuff. So I just call it web equals pdr.get data Yahoo. Just grab Google from Yahoo Finance. So in case if you're looking for the packages, then you're free to ask me, or you just Google on pip install whatever package that you need. So in my case, it's a pandas data reader in Python. Let's say I want to grab Google Yahoo Finance. So I should get this one, right? Google, G-O-O-G. So just grab that. Again, this is just an example, so don't pay attention. I'm just showing you a quick way to build your own backtest model. So Google, and let's print out web, just web. So I press F5, or in your editor, you just press run your Python script. I should be getting some stock data there. This is the stuff, and usually I need to get rid of the volume equals 0. That are the days that are not trade days. So we are starting from date 2009, December 31st, up to, I think this should be today's date. Yeah, October 31st. After you see that you can run the pandas data reader, you can start grabbing the data from Yahoo. So let me import pandas as PD. Then we are going to get only the trade days stock data. So I just create a new table called web1 equals web, which is the stuff that we get from Yahoo. Put a square bracket, and we are going to fill in the criteria. Our criteria is web bracket again. So you may be surprised why we get web, because we are going to call the web table. The column name is volume. So we just saw it before, and it has to be more than 0. So let me put web1 and see before we print. Let's see what we get. So press F5 or run it. It should be around, it should be the same. Then we are going to get the web1 stuff to Excel. So I just give it a name, web2 equals web1 dot to Excel. In case if you don't have XLRD without the pound key. If you don't get this package, you simply go to pip install, and which you can see from my other video, or you just Google that and it's easy to look up. So just to Excel, and I'm going to save it to somewhere. Oh, okay. So before that, I just name a destination called data source, and the data source is R, and then a single quote, and then I put in the path. The path is, let's say if I want to save it to D drive to folder, the tutorial folder. I'm going to save it to a new name called Go123, okay? So just put it here. Save it to D drive to folder. Just call it Google S.XLS. I'm using Excel. If you want to use CSV, feel free to do, but I just use Excel because I can manipulate the stuff. If you change to CSV, then you need to change this one to CSV also. So, and then I just put data source inside. Okay, so when I press F5 or I run the Python script, I should get a file. Yeah, here, Google. You see, Google test. So it's going to hold all the Google stock data. Oh, come on. How come? I think I know what's wrong. Okay, so let me do it once again. Maybe this way. Just press F5 again. Hopefully this time it works. So somehow we get it. Anyway, so we get all our data. Just make sure it's going all the way down. It happens sometime. I don't know why, but that's why we have to get our Google stuff. Our stock data directly to an Excel. You know why? Because I just showed you something strange happened. So after we get this, we can wipe out everything and start our programming. So we know that we have the data source in D drive to folder, and remember the name is Google Test. Usually we can start the next step by going to form our strategy. First, we have to read the data from our processed Excel file. So we need a library called import pandas, called pandas, speedy, and numpy, snp. And we define our data source just did equals R and then a single quote, D drive to its folder. This is our path, Google Test. We are going to save it to a table called df data frame equals pd, which is we are utilizing the pandas library. Its function is read underscore Excel bracket because it is an action presented as dot and then the action name in a bracket. So what we are going to read is we are reading from data source. Usually I'll check if we got the data correct. So we press F5 or run. So this time is way faster. So we are reading everything from the Excel file. So let's take a break. Let's get back to our backtest model. So after we can read stock data from Excel, we can start off creating our strategy. I'm coming from a non-science background. To me, it's just like writing an essay. For each essay, I just give it a title. It's just like if you're reading an article online, you see a title on every only 2 paragraphs. For each paragraph, it starts with something like define something. To me, it's just like that. For the first paragraph, I have to write a thesis statement. So it's just like this one, init self. In this example, I'm going to talk about an entry-level strategy called moving average crossover. So you need to define the long term, which is in this case is in trade days, in number of trade days, and short term. We define that the trade day is going up when the short-term moving average is going above the long-term moving average. When the short-term moving average is above the long-term moving average, we're going to buy stock. And also, if the short-term moving average goes below long-term moving average, we're going to sell stock. We need to define several things before. And we're going to calculate the moving average based on the adjusted close of the day instead of the close, because various reasons such as stock split, stock dividend, something like that. When we generate a signal, which is in later part, we're going to buy the stock at the open price of the day after the signal has been generated. Let's go to our strategy. Let's define a class for strategy. And first of all, we need to initiate it with an initiation statement. To define a strategy, just give it a name, and we use the self, this one, self, to refer to the title. Strategy is the convention, and so we are going to equal to tname. Outside strategy, I'm going to just call it global variable. We are going to define the tactic name. The reason why we define the stuff outside the class is that we want to add more flexibility. Inside the class, we are just describing the general behavior of that class. For example, for a special group of people, they like to throw garbage. But I don't know how many garbage they throw for each individual. So we can describe the throw garbage behavior for each person. Let's say 10. For MAV is 10. For LAV is 20. Something like that. And go back to our example. We need to define the long-term day, which is, we just call it long win, which stands for long window. And again, in the global variable sections, I just call it long window. Just give it 20 days. You can always change the long win to like 200 days or whatever. And we define the short window, short win. The short win to be 5 days. And the next thing we need to define is the condition that we start our calculation. So just give you an example. Just go back to my example. These are the stuff that we just grabbed from Yahoo Finance. We want to calculate the moving average on the adjusted close. Let's say if I want to calculate the 20-day moving average, then we need 20 days of adjusted close data to calculate. So we need to start with the index 20. So that's why we need to define the calculation condition to be the table index, which is just like counting each row. We just count the first row as 0, the second row as 1, and so on. The index has to be more than or equal to the day when we start calculating long win. It's just like the 20-day moving average, then we start calculating on the 20th day. So it's like that. So let's say our calculation condition equals to is assigned to be the DF. What is a DF? DF is the table that we just create, and it's starting from the index has to be more than or equal to self.long win, just like the 20-day moving average example. The next one is the trade price. So we need to define what price we are going to trade. Trade price is equal to the table column open, because we are going to trade at the open price. Okay, and the next one is the close price. The close price is the close price that we are using to calculate our moving average. So it's the adjusted close. Let me run it, and I can show you the stuff here. So we are using the So we are using the adjusted close to calculate the close price. Our trade price is the open price, and this is the index 0, 1, 2. So we are starting to calculate our moving average here on the 20th day. For the long-term moving average, just take a break. We are going back to our backtest model. So at this stage, we are going to calculate the short-term moving average and a long-term moving average. Okay, let's get back to the code. So it's just like writing a paragraph, and we start a new paragraph by defining short-term moving average. I just called it SMAV. From the programming's perspective, this short-term moving average is part of the strategy class. So we just put a bracket of self to relate to the strategy class. I just called it an instance called self.smav. It equals to the close price, which is the adjusted close, rolling for whatever window. So in our case, it's a short term. So here, we will use the numpy, which is abbreviated as NP. We use the numpy.where function to do this calculation. When the condition we start calculate, then we do calculation. Otherwise, we put 0. So in this case, I'll just rub this part first. Also here, where condition, which we defined earlier here. So where strategy class, before we use the instance of strategy, we need to include a bracket here. I just treat it as a syntax for object. Okay, that's what I learned. And dot cal condition, which is this one. We don't need a bracket because it is not a method. It is an instance in the class strategy. So in case I'm calling it wrong, feel free to correct me. I'm not a programmer. Once we get where this condition holds, we start calculating the moving average. The moving average of what? Of strategy class close price, which we defined earlier here. It is the adjusted close of our table df. The adjusted price, the close price, dot rolling, and then dot min. Let me fill in the window equals what? Equals the short win. Again, we need to, it's part of the strategy class. So we just call it short win. Oops, let me move out. Let me recap. Okay, we take the min of what? Of the short-term rolling of the close price that we defined earlier. So after that, we return the instance SMAV. Usually under the global variables section, I'm creating a new column SMAV in the table df to be strategy class dot SMAV bracket. Why I use bracket? Because it is a method under strategy class. And you may say, oh, how come it's so cumbersome if I have to type strategy every time? So I can define S equals strategy class, so that next time I can simply use S. So let's run it. Press F5. See if I get, oh, it's not defined. Oh, you know what? You know why tname is not defined? I always get it wrong. I think I have to put strategy underneath. And let's try run that again. F5. Okay. So this time should work. And you see, SMAV, the short-term moving average, starting from day 0. From day 0 to day 20, I don't do any calculation. SMAV, as you can see here, 0, right? 0. But starting from the 20th day, I start having the moving average from, it's like this, moving average from here to here. Start calculating the short-term moving average. And I can do this for the long-term moving average as well. The long-term moving average is easy, just getting lazy. So I just copy that. And then I start a new paragraph and I change it to LMAV, long-term moving average. The condition stays the same because we start calculating from the 20th day, the long-term day. And then we are calculating, so you can just change the rolling condition, which is here. The rolling, which is this one. So I just changed the short wind to long wind. The long wind that we just defined here and here. Everything stays the same, and usually I will print this out also. LMAV equals S dot LMAV bracket, and then I press F5 to run. Okay. Oh yeah. So I'm calculating the long-term moving average. So it starts from row 20, day 20. Okay, just take a break. Okay, so after we calculate the short-term and long-term moving average, we are going to define the day when the trade day is going up and the day when the trade day is going down. So the trend day is just when the short-term moving average is more than the long-term moving average, then we call it an update. Let's call it 1 when it goes up. Otherwise, when the short-term moving average is below the long-term moving average, I call it -1. If it's neither up or down, I just call it 0. Let's go back to our code. So we just define a trend day. And the variable is trend day equals, we use the numpy.where again. If it is up, then we put 1. Otherwise, we have numpy.where. Otherwise, if it is down, then we put -1. Otherwise, it's 0. Okay, so we follow this format, and we can just change the update. What is the update? When strategy class SMAV bracket, the method is more than the strategy class dot LMAV method, then it's going to give me 1. I just put float. Otherwise, you see the comma? Otherwise, if the strategy class dot SMAV, it's below the strategy class LMAV, then I get -1. Usually I put float to wrap around the number because float is reading faster than integer. Okay, otherwise 0. Okay, and then we return self is pointing to the paragraph head, which is the trend day. Trend day. So usually I will print it out to see if I get it right. You don't need to, because I just want to show you here. So you don't need to print it out. DF. So I create a new column in DF called trend day. Single quote and then close with the square bracket. Equals strategy, which is S here. S dot trend day. It's a method, so I put a bracket. So let me run it, press F5, so I get all the days here. So you see the trend day, when the LMAV, long-term moving average, is more than the SMAV, short-term moving average, I return -1. So let's pick a day when we have 1. So for this day, 1948, short-term moving average is more than the long-term moving average. So I get 1. Then we move on to the previous trend day, because we are going to compare today's trend day and previous day's trend day to determine whether this day is a turn of trend. Okay, let's say if this one, the previous day was a down day and today is an up day, so it's the day that the price turned. Let's do the previous trend day first. So for the previous trend day, we open up another paragraph. We just called it previous trend day. It's also a method in the class strategy. Okay, and we have the instance self.previous trend day. It's just roll. Okay, we can use the numpy.where again. Numpy.where when we start calculating moving average, so we can simply copy the condition here. When we start calculating the moving average, we start rolling back one day, so that we can get the previous day's trend day, right? Otherwise, it's 0. So for the rolling part, we just use the numpy.roll and a bracket. Then we put in a condition. The condition is, put a comma here, we are rolling which column? And then we roll by how many days? 1 day. I just put float this one first, and then I change the column to strategy dot trend day. It's a method, so I put a bracket, and then I put return self dot previous trend day. Let's print that out to see if we can get it. So create a new column in df. So it's called previous trend day. It equals to strategy class previous trend day method. So let's try by running it. F5. Let me see what happened. Must be integers. Okay, so maybe let me change this one. I think it doesn't matter, but okay. So
just change this to, just remove the float. Sometimes it happens. I don't know why, but maybe we can change it
just
afterwards.
put 1. Okay, let's see if I'm right. Okay, good. Let's run that again. Yeah, good. So we get it. This time we have the previous trend day. For this day, 1948 is an update, and the previous day was a down day. So we get it here, so you can always compare. Then we can move on to the next one. Okay, once we get the previous trend day and the trend day calculated, we have to return a value of the difference between the previous trend day and trend day, so that when we move on to signal, we can use this difference trend day to get us a trade signal. So we need to open up another paragraph under strategy class. Okay, so get back to the code. We need to define a diff of trend day, which is also a method underneath strategy class. So the self.diff trend day equals to simply the strategy class trend day plus strategy class previous trend day method. These two. So when you add them up, you will have a value. So return self.diff trend day. So let's print it out to see if we get it. So create a new column called diff trend day. equals strategy class def trend day method, and press F5 to run it. Very good. Let's grab a day. This day 1947, date 1947 and 1948. The previous day was a down day and today is an up day. So let's see if we get 0 for 1948. Previous trend day is negative 1 for day 1948. Today's trend for 1948 is 1. 1 plus -1 is 0. So we get the difference trend day to be of day 1948 equals 0. So it is a turn of the trend. Okay, so just take a break. Okay, let's go back to our code. Let's get back and create a class called signal. Initiate it just like writing a paragraph. And but anyway, so define the tray signal is the method, and we have the instance tray signal. We use the numpy.where. When our strategy, which is here, strategy dot difference trend day equals 0. So it's a change of day, right? Then I return the trend day, because the trend day has all the 1 for up day and the -1 for the down day. So if we have the difference equals 0, so it's a change of trend, so we return the trend day, so it has the 1 or -1, otherwise it's 0. Let me just change that. We have to call the strategy class dot diff trend day. It's a method, just put double equal sign equals 0. Then we have to return the trend day. It's also under the strategy class, so let's return the trend, otherwise it's 0. And let me return self.tray signal. Let me print that out to see if it works. So again, I don't want to type signal, so I just put TS. It stands for tray signal, so it's equal to a signal class. So let me print that out. In the df table, just call tray signal. It's equal to the TS dot tray signal. Let me see if it works by pressing F5 to run. Oh, how come? Let me see. It happens sometime for the module equals tray signal. How come? Tray signal. Maybe I spell, yeah, signal. Okay, tray signal. So it's a typo. So press F5. Should work this time. Yeah, very good. So when we see the difference in trend day equals 0, so we have the trend day for, let me see which one. This one for 1948, date 1948. It's a turn, right? So we return the signal. The signal is what? It's 1. Why? Because it's going to return 1948. The trend day column, which is this one. 1948 is 1. Okay, so it works. So we can move on to the order. After we generate the signal, we have to place an order to buy, right? But we cannot buy any stocks for a day we generate the signal. We generate the signal after we know the close price of that day. That's why we have to buy according to the previous day's signal. That's why our order is always coming after the trade signal. Okay, so let's get back to code. Okay, so we start another paragraph by creating order and self.order. This instance equals numpy.where where we start, we use the strategy objects dot calc condition. So it should be this one, the one we just created before, self dot calc condition underneath strategy. So it's the dot calc condition. So we start calculating the average, the moving average, under the strategy class object, the strategy class. Then we use the numpy dot row. We row by how many days? 1 day. And we row which column? We row the signal column. So we are going to row the signal class dot tray signal, because it's an object, so we need a bracket. This is the tray signal dot tray signal instance, which is here, and it's under the class signal. So we return 1. So this one is the numpy dot row. So we roll back 1 day to look up for the tray signal from the previous day. Otherwise, we put 0. So return self dot order, and let's print it out to see if it works. So equals, again, it's under signal class. So signal class, we previously defined it as TS. So we use the abbreviation TS dot. It is a method. We just put the method name, which is order, and in a bracket. So let's run it by pressing F5 to see if it works. Hopefully it works. Yeah, it should be. So under the tray signal, when we see a tray signal 1 or -1, on the day 1948, our signal is 1. So the day after, which is 1949, we have a 1, which is a buy signal. A buy order. For 1969, we see a -1 signal. So the day after, we have a sell signal, -1. Ask, if I don't have enough money, how can I buy? So that's why we have to go back to our assumption that we can buy whenever we want. So we can borrow money without needing to pay any interest. It's just theoretical, and it's just testing out whether we follow the logic we defined in the strategy class. We just let you know. Okay, anyway, now we are going to the last part of our backtest model, and now we are going to create a portfolio class to capture the trade details. The lot size long means when you execute the long order, when you long call something, how many lots are you going to buy? When you sell your stock, how many lots when you sell? And so it's the contract size, it's the shares per lot, and initial cash is your startup capital. So let's go back to the code. So we start a new class. It's called portfolio, and we are going to initiate it. And the first one is we need to define the lot size when we long call an asset. Stocks, is a long only strategy because we only buy stock and sell stock. So we have the lot size long equals lot size long. So again, we define this stuff here. Lot size long equals, by default, I just set it to 1. It's just 1. You just buy 1 lot of share. And the same for the short size, sell size. So lot size short is here going to be, I just set it to 1 also. It just adds more flexibility when you define the number of shares to buy under the global variables section. Instead of doing it in a class, you can set for every execution you buy, long order, you buy 5 lots and you sell only 2, something like that. Okay, but in my case, I just set it to 1. I need to define the contract size because for each lot it's going to be 100. Contract size, so contract size is going to be 100, and you can also set like whatever period, then it changed to 100, otherwise it's going to be like 500, something like that. But in my case, for simplicity, I just change it to 100 shares. Let me see what else we need. Oh, okay. We need to set the initial cash, the startup capital. Again, we do it here, initial cash. I just set it to like 1 million. We start off with 1 million. Okay, and then we need to create an instance called long amount to determine the amount that we are going to pay when we execute the long order, when we buy stuff. First of all, when we pay, I just multiply -1 to any amount that I'm going to pay. So negative cash flow means I'm going to pay. Okay, so just get that in mind. When the signal, we use the numpy dot where again, when the order is 1, so I'm going to buy, then I'm going to multiply the lot size long, the number of lots that I'm going to buy, times the number of shares inside one lot, and then we multiply the trade price. The trade price was previously defined as the open price of the day. That's the amount we have to pay when we execute the long order. Okay, so we put that in the code. So it has to be the long amount. Oh, sorry. It's going to be numpy dot where. When the order equals 1, so we are going to pay whatever amount. Otherwise, it's 0. Okay, so we just replace this one with the signal class dot order is a method which we define here. The order under signal class. When the order equals, we use a double equal sign, equals 1. Then we pay amount. We pay, the amount of pay will be equal to -1 times self dot lot size long, because we just define it here, self dot lot size long times self dot contract size, which is here, number of shares per lot, and then times strategy dot trade price, which we defined under this one, under the strategy class is here. So trade price and the self points to strategy class. So we need to include the strategy bracket. That means as an object dot price. Otherwise, it's 0. So let's see if it's okay. I'm going to print out the lot size long, see if it's okay. So long amount equals, I don't want to type portfolio, so I just add P equals portfolio class, so that here I can put P dot long amount. It is not a method, but just an instance. I can simply ignore the bracket. So let me press F5 to run. So every time when I see the order is 1, I have a negative number of cash flow. So let's do it. Let's do the short amount. The short amount can be quite easy because we can simply copy the long amount by changing it to short, and the order equals -1. So it's a sale signal, the sale order. So I don't need a -1. So you can remove that, but my convention, I'll just keep it, but I change the vector, the direction to +1, and it's not going to multiply the long size, but the short size. and the contract size stays the same. The trade price stays the same. So let me print out the short amount to check if I'm right. Short amount equals B dot short amount. So let's press F5 to run it. So for a day, let me pick a day when we have order. When we have order equals -1. So this day, 1970, it should be a positive cash flow coming in. So we have this one coming in. Okay, so, and indeed we don't need the long amount and short amount, so we just comment that out. So let's take a break. So after we calculate the long and short amount, we are going to determine the daily change of cash flow. I just give it a name, cash delta. It's just equal to the long amount and a short amount. And we know that the long amount is a negative number and a short amount is a positive number. In this example, you may not have the need to separate the long and short amount. If you want to expand your system, let's say if you want to do some long and do some short operations in one shot, and you have to separate the long and short amount. So let's get back to our code. Oh, excuse me. We have to get back here. We have to define the cash delta, the method cash delta, and create an instance. Cash delta equals portfolio dot long amount plus portfolio class short amount, and then we return self.cash delta. Then we scroll all the way, hold on, down, and let's print out the cash delta. We use this one to calculate our ongoing cash balance underneath the portfolio class, and it's a cash delta method. So let's press F5 to print it out. Yep, here we go. So usually when I see 1 in the order, I will have a negative number. And a negative number in the order, I will receive money because I sell stock and get money. Okay, so this is the daily cash change, the change in position of cash balance. Okay, so let's move on to the next one, our portfolio's ending balance. It's an ongoing ending balance. It's just equal to the initial amount of cash plus the sum, the cumulative sum, which is represented in .com sum bracket, is a method of the cash delta of portfolio. So it's accumulated amount of the daily change of cash plus the initial amount. So we create an end balance instance, and it is an instance called end balance equals portfolio initial cash, which we define here. Initial cash, the $1 million plus the accumulated sum. Usually I type it like this. I type the method. The accumulated sum of what? Of portfolio class dot cash delta. It's a method here. The daily change of cash, and then we take the accumulation. Okay, so we return self.end balance. Let's print it out and see what we get. The iPhone keeps blocking my way. Anyway, I just press this equals the portfolio dot end balance method. So let's print it out by pressing F5. Should be fine. Yeah. For this one, you know what? because we have more than a big number, because it's going to be 10 to the power of 7. So it's about 1 million. That means it works. And the next one we are going to calculate is the ending position. Once we calculate all the things in portfolio class, we will calculate the profit and loss in a global variable. We just think each portfolio has its own profit and loss because they have different parameters. The logic are the same. So we are going to calculate the ending position. So we define the end position, that is the stocks or assets position, is equal to the cumulated sum of the order. We assume that we start with 0. So for the instance end position, it equals to sum, the method sum of it's not portfolio, it's signal class order. Signal class order method. Then we calculate, we get the order, and we sum up the daily change of position, which is defined by the orders, by taking the accumulated amount. So then we turn self dot end position. Let's print that out in our DF table. End position, the column end position equals portfolio dot end position method. So we put F5 and run it. For this one we have 1949, pay this amount 94,000, and then we buy the stock, right? One lot, right? Then we have this one, and then we sell at the date 1970, and we go back to 1970. We sell stock for this amount, sell it, and then we get money. At the day of 1971, we buy again by paying this amount. That's why we are going to test it afterwards. Okay, so take a break, and then after the break, we will calculate the profit and loss under the global variables section. Okay, so let's get back to our backtest model. In order to calculate our portfolio profit, we need to determine the total asset value of our portfolio. It has two elements. The first element is the running total of the cash balance, and the other part is the unrealized value based on the positions we hold at hand. Let's say if we have no buy or sell signal received at the date that we are going to calculate portfolio value, we assume that we are going to buy or sell at the date's open price. Okay, so let's get back to our code. Do that in the global variable sections. We are going to create a total asset column equal to the ending balance, which is this one. Ending balance, this is the cash balance at the date of cutoff, plus the ending position times the trading price, which is the day open, times the contract size. So we can just contract size, because we define the contract size here. Let me fill in the blank. This one is the position, which is N portfolio dot end position bracket. So let me run it to see if we get it. Oh, it's not callable. So that means we cannot comment these two out. We can just change it to DF end balance times the DF end position. So let's see if we get it. So let's press F5 to run again. So this time it should work. So we have the total asset. Again, it's a very big number because we start off with $1 million. You see, the total asset value keeps changing, even though if we don't change our position. Our ending position doesn't change, but our total asset value keeps changing because of this element. The opening price keeps changing every day. That's why it's going to have different ending total asset value. Okay, so let's plot the graph profit and loss to see what we get. Underneath the table, plot the graph. We need matplotlib.pyplot as PLT because it's very long, so I use PLT. And before we print anything, let me create a new table, a new data frame. We call it df1 equals to df.setIndex because we want our x-axis, which is the horizontal axis, to be the date because it's easier to view, right? So we just put date, and then our profit and loss equals, I just called it P&L print equals, because we are going to plot this one, right? The total asset. So it's df total asset, this column, and then do dot plot. That means we are going to take the dot plot method on this column, the data frame total asset. Oh, I think it should be df1. Then we can start plot it by plt, which is this one. plt, the matplotlib.pyplot dot show. Show what? We show P&L print. Okay, so let's print it. F5. And we have a very nice graph here. This is 10 to the power of 7. So we start off with $1 million. And it goes down a little bit for 2011. And then it starts going back up. This is how our portfolio performs. And again, we need to be aware that we assume that we can buy as many stocks as we can sell it without having owned the stock. So that is the consumption. Hopefully it helps. Thank you. Bye bye.